All right, let's start. Again, I'm Benjamin Pirotte. I'm a product manager at Soda. I'm going to be your host for today's webinar, where we are going to cover data contracts and data testing in the modern data pipeline. Before we start, just for your information, this webinar is going to be recorded. We are going to make it available on YouTube, and we will share the link. So if you want to review it after, you will be able to do so. All right, so to start, let's do a brief introduction about Soda and what is Soda. So basically, we are a company working on the data quality. We propose data quality solutions which are end-to-end. So what we want to achieve is basically three things. Is one, helping you to find data quality issues, understand them, and then fix them. So to make sure that basically you can prevent them to happen and also fix the ones that are happening. Today in this webinar, we are going to focus mainly on the find section and actually in the data contract part, because we have different ways of finding issues. And in this webinar, we are going to focus only on the data contract part, which is going to help you to basically define the exact data behavior, make sure that you have an agreement between data consumers and data producers, and actually test those requirements to make sure that the data is compliant. Another part about Soda, so we have a few components which I'm going to demonstrate today. So the first one which I'm going to mainly use today is our Soda core. So it's a OSS Python library that you can basically install and use. So that's going to basically the engine that is going to take the data contract that we are going to build and test that the data is actually compliant to this contract. On top of that, we have a component which is called Soda Agents, which is basically an orchestrated version of Soda Core, which is running on Kubernetes. And this is going to allow our user interface, which is called Soda Cloud, to actually run Soda Core and basically run from the user interface contract verification and over things like data observability and so on. And the last part that we have, which is here on the right corner, is our Soda Cloud, which is our user interface, which is running on AWS, which is basically kind of the control plane for your data quality. So we are going to be able to push all the results there to basically create notification from the contract verification and basically have everything centralized here in this user interface and make it accessible to everyone in the organization so that they can understand how the data quality is. The last part is, so Soda is only one part of your data stack, of course. So the data quality is an important part, but it's not everything that you need for your data stack. So for example, you have like catalogs or orchestration, and of course the data sources. So Soda seamlessly integrates with all those components. So we support quite some data sources like Databricks, Snowflake, Postgres, and so on. We integrate with data catalogs like Atlant, Colibra, Alation, as well as communication tools. So, for example, sending alerts when there are data quality issues with Slack or Microsoft Teams or PagerDuty. And we support also integration within your orchestration tools, which support Python. And so today in the demo, I'm going to focus mainly on the data source Postgres and the orchestration Airflow to show you end-to-end how data contracts can be implemented. All right, let's do a bit of theory around data contracts before we move into practice. So that's basically what we are going to cover today with the agenda. So I will explain first what is data contract and why it matters, how does it look like, so the anatomy of data contract, and then we will move into the practice, the demo part. All right, so what are data contracts and why do they matter? So a data contract, the goal of and the intent of a data contract is basically to create an agreement between the data producers, so the people responsible for producing the data, responsible for the data pipeline that is going to produce the data, and the data consumers. Who are the data consumers? Is basically the people that are going to have a use case, don't stream for the data. Think about, for example, reports, like analytics reports, or even another application consuming this data, or a machine learning model, so like data scientists that are going to leverage this data for machine learning and so on. So here, what we want to achieve is basically an agreement between those two personas to make sure that basically there is an understanding of what the data looks like and what are the requirements for the data. And we are going to make it as explicit as possible. What are the requirements for each of the columns for the data set? So, for example, can I have missing values? Can I have what is the validity for a certain column? What is the freshness that is expected? What are even the columns that are expected with my data sets? And we are going to make those expectations explicit and testable, which is a really important part here. We are not going to only document the data, we are also going to test it to make sure that what you have documented actually respects the reality. Which is something that is quite important. So if we look at the data governance use case, basically that's where data contract can use a lot, be useful a lot, and especially for the data engineering people, because historically data governance was mostly about describing the standards, describing the data, and basically make a definition out of it. But it was all on paper and not enforceable and testable. And here what we want to do again is basically make sure that what you have within a data contract is something that you can version, that you can keep a history of it, and that you can test as well. And that you can have real life cycle where your contract is going to evolve as you pipelines are evolving, as your data is evolving, and that every time you can actually test the data against your contract to make sure that it's always in sync. The anatomy of a data contract. So how does a data contract look like and what do we find in there? So what we chose as a format in Soda is basically to use YAML. Why do we use YAML for the contract? The first reason is that it's compatible with any Git-based version control because it's a file. So that means that basically we can version this contract. We can have pull requests on top of it. We can have make it a testable artifact that every time we create or do a change, we can test that the change is valid. So we can really integrate it into an engineering workflow. As I mentioned, we can then have pull request review. We can understand what are the differences, are the evolution with a line-by-line diff, and even do version rollback if, for example, you do a change in your contract which is not correct and roll it back, basically. Then we have the readability. So YAML is fairly easy to read. So that means that all personas can read and understand what is within the contract, which is again really something important because here we are not only talking about data engineers producing data, but also people using this data. So it's important that analysts, domain experts, business users can actually understand what is the data contract and what is enforced within the data so that they can rely on it in their use cases. And the last part is a bit related to that, is that even to write it, it's basically only required to understand the structure and the indentation, and required to understand a bit of language, but you don't actually need a programming knowledge to create a contract and to enforce it, which will make it quite powerful, meaning that even less technical users will be able to create a contract and test it without actually having to write Python or having to write advanced programming language. Sorry. All right, so this is basically a contract or a part of it, and we have a few things here. The first part is the dataset information. So every contract is going to be tied to a single dataset, and we have this information on which dataset is covered by this contract here, which is something that is really important for Soda so that they know where to access the data so that we can actually test it after. Then we have two sections. The first one here is the dataset level checks. So there we are going to have things that are not tied to a certain column, but tied to a dataset. Things like the schema check, making sure that the columns that are defined in the contract actually are in the data itself. Things like making sure that there are some rows. Things like making sure that the data is fresh and so on. And then we have the columns, where basically what we are going to have within the contract is the list of all the columns that are within the dataset and available, as well as their data type. And then we are going to be able to add checks on top of it. And here, what we are going to have is things like, can my column have missing values? Yes, no. Can they add, well, what are the valid values? For example, we can have a regex check, or making sure that the values are within a certain range. And basically making sure that what is within this column actually makes sense. And that's going to allow us basically to make sure that at all levels we have the data that we expect, and that we are going to enforce it right after. Another point on Soda and the other data contracts solution out there. So there are several other data contract solutions that are present in the data environment. We Well, basically, the main difference with Soda and the main value of what we have done here is that what we want to offer is something that is fully executable and enforceable. So a lot of other vendors, they allow you again to basically create a contract which is going to document the data itself, but not going to allow you to enforce it, making sure that this contract is always up to date and the data is always correct. So here at Soda, we really want to focus on the data contract aspect of making it enforceable, so that you can make sure that it's always up to date and that the data is correct. All right, so that's basically the theory, and so I'm going to show you how with Soda you can actually create a contract and then enforce it. Just before we go into the code, let me just explain what we are going to do a bit more into detail. We are going to basically embed Soda into a pipeline. So in this use case that I'm going to show after for the demo, let's imagine that I have an order table which exists in Postgres, and that basically every now and then I have an Airflow pipeline which is going to take a new batch of data and going to publish it into this production or in my Postgres order table. What I want to do is making sure that this orders table, which has a few columns, always have good quality because it's being used by some downstream systems. So to do so, the first step will be to create a contract so that we can start documenting what orders table should look like and what are the rules that we want to make sure that the data basically support. And what we are going to do next is basically every time that there is a new batch of data, we are going to load the data into memory, run Soda on top of it to make sure that basically this new batch of data is good quality. If everything is fine, we are going to publish it into Postgres. And if it's not fine, we are going to stop the pipeline. This way we make sure that there is never bad data reaching the production system. And once we have published the data, if everything is fine, we are going to do a last test of running Soda again on my production data, not on the batch, but on the whole data set there, just to make sure that everything went fine when we published the data and there are no issues in production. This way we prevent that there are issues in production, and then we also make sure that we test the production database to make sure that if so for some reason some issues happen in production, that we can actually get an alert which will be visible in Soda Cloud and trigger some notifications on Slack or Microsoft Teams and so on. All right. Just so you know, what I'm going to show today, I'm not going to be able to go really into details of how to code the full pipeline, but we are going to send you a Git repository, so a link to a Git repository after the webinar. So if you want to basically explore a bit more yourself, you will be able to clone the repository and test it by yourself. All right, let me switch to my ID, and we will start by creating our first contract. So before I do that, just to give you a bit of an explanation of my environment. Soda, as I mentioned, Soda core library, which is a Python library, which you need to install to be able to use Soda programmatically. So that's what you can see here, my requirement .txt. So I have two Soda packages. I have Soda Postgres and Soda DB. So basically what we do is that we provide a package for each of the data sources that you want to use. For example, here Postgres DB, but you could have Databricks, Soda Snowflake, and so on. I have a few over dependencies here because what we are going to do here is my Python is going to generate a Panda data frame with new data that I want to push in my Postgres. I'm going to use DuckDB to basically load things into memory before I actually run Soda on DuckDB. And then the rest is mainly just to make sure that everything works. And the last part is basically the Apache Airflow, which is basically the pipeline that I'm going to hook Soda into. Next to that, we have two configuration files here. So the first one is my DB config. So that's basically a YAML file as well, which is going to provide the information, the credentials on how Soda can access my Postgres database. So basically what you have here is all the connection credentials like host, port, and database and so on, which is going to allow Soda to connect to the database, and then test the data based on my contract. The last part here is my Soda Cloud configuration. As I mentioned, we have a user interface called Soda Cloud. And this is going to allow me with the API keys to basically connect to Soda Cloud so that I can later push results of my contract execution to Soda Cloud so that other people and notification can be sent every time there are new issue popping up. Once I have that, what I can do is actually use a CLI here in my terminal just to make sure that everything is fine. So what I'm doing here with a little shortcuts, I'm actually running the CLI in the background, running Soda data source test and using the YAML file that we defined here. And we are just going to do a ping to the database to make sure that everything is fine, which is the case here. And we are going to do the same with Soda Cloud, just to make sure that I can connect to the database and I can connect to Soda Cloud. And from that moment, I'm basically ready to use the CLI and I can generate my first contract. And so to do so, I can use a CLI, which is going to basically help me to generate a contract skeleton, which going to basically connect with the CLI to my Postgres. Is going to fetch the columns available within my Postgres table and create a skeleton of this contract that I will show just after so that I can start adding checks on it. So if I execute this, so what you can see here is that basically I provide the path of my data sets within my Postgres database. As well, I also generate automatically output file, so that's basically where I'm going to create this contract, the contract YAML file, and also provide two things, is basically my DB configuration and so that cloud configuration so that I can connect to the database to actually fetch that information. And so what we are going to run in the background is basically this CLI command, which is using the information that I just described before. And what we can see here is that we saved a file, which I can access like this. So basically what we just did is creating a contract file within my contract folder. And I can see here basically my contract that I just created. So as I explained before, I can see a few things here. The first part is the data sets, which is basically here the path where my data set is located. which is in my Postgres in the public schema and the order table. I can see all the columns that are available within my dataset, as well as a check that we had by default, which is a schema. And what we are going to do here is basically when I run my contract, we are going to validate that the schema that I defined, so basically the name of the columns and the data type that is defined within my contract is valid. And what I propose is that we start by doing this. And so what I can do here, again, let me just clear this. I'm going to use, again, the CLI to basically verify my contract. Verification meaning verifying that the data is matching my contract. And to do so, I can use, again, the CLI to basically point to this contract file that I have. Which you can see here with the dash dash contract, which is referring to the contract that I just created, as well as the data source configuration, because again, we need to be able to access the data set in the database, as well as the Soda Cloud configuration, because we are going to basically publish the results so that it will be visible in the Soda Cloud, which I will show right after. And so that's basically executed my contracts. And then I can see here the result of it in my CLI. I can see that I have one check which passed, which is basically my schema check. So it seemed that what I've defined within my contract is actually matching the reality, which makes sense because we actually just generated the contract a few seconds ago based on this actual structure. And what I can see here is that I can actually then see the results within Soda Cloud as well, which I will show right after. What I propose to do right before that is that we can actually start adding a few basic checks. And let me take the order ID as an example. So we can start adding a few checks to make sure that this order ID column is actually valid or don't have missing values and so on, which is the case here. I don't want order ID, which is my primary key, to have missing value. Don't want, for example, my order ID to ever be duplicated either, because it's a primary key, so it cannot be duplicated. And I can keep on going like that. So here I'm using the missing check, the duplicate check, but I can also check the validity of my order ID. For example, here, let's say it's a UUID in a certain format. I want to validate that, which I will show just after. I can use the invalid check. And I can do two other things. One is the aggregated check, which in this case doesn't make a lot of sense. But for example, here, I could say that the amounts up here aggregated. And the function, and I want that the average, let me just make sure I didn't, is meeting a certain thresholds. So maybe let's be less 100, for example. So I can here for a numeric data type actually also check things like average or sum of my amount. Anything that makes sense, basically an aggregated metric, and check that against a threshold. The threshold being something that you can define for any of the checks. For example, if let's maybe just take the missing here, I can define a threshold here and say, for example, must be less than 10, and say, for example, that the metric is going to be %. So in this case here, I'm going to allow at least or maximum 10% of missing values, and it will only fail if I'm reaching that threshold. Let me clean this. As we will add more checks after. And the next part here is the checks on the dataset level. So as I mentioned, there is the schema check that was already added, and we have a few other checks here that you can add. You can add, again, the duplicate check, which allow you here to have check on duplicate logic on composite key. So if you have multiple columns that you want to check for duplicates, you can actually do that here. You can check for the freshness. You can check for the row counts, and the two last ones here, the matrix and ferrows, allow you to do a bit more logic into like basically combining multiple columns, like comparing one column with another, and identify, for example, which I will show after, for example, if my order date, which I have here, is lower or later than my shipping date, that doesn't make a lot of sense because shipping date should always be after order date, and that's going to allow me to do that. But I will show a bit more concrete right after. For now, let's just keep it to those two checks here on my order ID, which is missing and duplicate. They are very straightforward checks. So I'm just going to test it and make sure that everything is fine within my Postgres, which seems to be the case here. I can see again my overview that now I have three checks, and on my order ID I now have no duplicate values and no missing values. I can see how many rows were tested within my check, and I can see that the missing count and the duplicated count are actually zero here, which is good. All right, so I have now a really basic contract. So what I propose to do is actually transition now to the user interface. Let me just access here. And so let me just refresh to make sure that it's showing the latest. But basically here, I'm now on my user interface, so cloud.soda.io, where there's basically a representation of what I've seen before in my CLI, but within the user interface. So here I'm on my orders table, which is within this path. And I can see here the contract results. So I can see the three checks that I just created with the schema check and the no missing values and no duplicate values. And I can see that everything is green. So anybody that has access to Soda Cloud can actually visualize those results and understand what is the quality of the data set. They can also access the contract here and understand as well what is the evolution with the contract history, but also what is the current version of the contract. So they can really understand as a stakeholder what is being enforced and what is not being enforced yet. Let me actually use this to continue on working on my contracts because that provide actually as an author of the contract or owner of the contract a quite convenient interface to create checks. So I created only three checks at the moment, and let's assume here that I have actually a ticket from, for example, my data product manager, and that has certain requests or things that I need to implement. So in my ticket, I have a few things. So for example, I should not have any missing values in those columns. I have a certain validity check that I need to create. For example, amount can never be negative. Status column can only be one of those three columns. Country codes must be to letter formats, some basic address sanity, making sure that the lane makes sense, and then testing the UID formats, as I mentioned before, on those two columns. And also, as I mentioned, we want to make sure that the shipping date is also always after the ordering date. And then two checks that we already implemented, the schema check and the duplicate detection check. So I'm going to basically use the UI to do that and then transition it as code. So if we go back here at the interface, what you can see here is basically a user interface on top of the contract YAML. So I can see the same information as what I have in the YAML. I can see, for example, that I have my schema check here on the dataset level. I can see all my columns and the two checks that we created. The nice thing here is that I can actually start adding checks from this UI. And then, for example, if I add a simple row count here, just making sure that there are rows in my dataset, I can actually see that this check has been added to my YAML as well. So basically, we have within the user interface the possibility to use both a UI version of it and a YAML version of it, which allow me to, even if things are done within the UI, I can still actually extract the YAML and version it and put it in Git and so on. And we have APIs to basically do that. But what I want to use here is actually the Contract Copilot, which is even better than a user interface where you can click button. The Contract Copilot is going to basically help me to translate those requirements that I went over just before within my ticket into actual contract specifications that I will be able to test after. So if I go back to my ticket, I have a few things here, and I'm going to do one by one. For example, I'm going to say that Copilot, I don't want any of those columns to be missing. So I'm just going to copy the requirement here, and I can see now that the Copilot is actually adding those checks for me. So I can see with the little A here, that's basically those checks were just added, and I can see that for all of my columns now I have a no missing value check that was added, which is by default basically making sure that there are no nulls value. And what I can see here on the side is also like explanation of what it has done as well as notes. So for example, make sure that you captures empty string for text field using missing values if needed. So for example, if you use a dash as a missing value in a certain field that you consider that. But in this case here, I'm happy with the default behavior of checking there, so everything is good. I will move then to my second requirement, which is the validity. Let me just copy all of that. So this is a bit more complicated, might take a bit more time, but let's be patient. All right, not too bad. So we can see now that a few extra checks were added. So for example, on the dataset level, I can see now that I have a firewall check that was just added, making sure that the shipping date is smaller or equal to the order date, which I think is actually the other way around. But I think the requirement was not correct. Anyway, then we make sure that the order UID v4 is correct. So in this case, basically we have a regex that is going to validate that the format of my UID is matching this. Then we have the same here for my customer ID, and then for the shipping address, we are basically now checking that the minimum length is 5 and that the maximum length is 200 characters. We have now our amount, nonce that should never be negative, which now basically has a valid min of 0. We have our valid values for status. So we have defined here that it can never be something else than pending and shipped and cancelled. And then the last one is basically making sure that the country codes column has only 2 characters. So again, with a regex here, or can be also with a valid length. The Copilot decided to use a regex, which is fine. This one, remember now, is basically because this expression is actually expressing what is a fair row and not a passing row. So that's basically why this is the case here. And I think we can actually correct it like this. So now basically I'm happy because I basically implemented all my checks. As you remember, those 2 ones we added them before, so no need to add them again. And what I can do is actually use the UI, and in this case Soda agent, so the orchestrated version or the managed version of Soda Core, which is connected to the Soda Cloud, and that I also configured to be able to access Postgres. And actually I can then run this through the UI to make sure that everything is working. So it's basically similar to the CLI, but in this case here, I'm just going through the agent and see what's happening here. And I can see that everything is green, which is great. Everything is 0, so I don't have any issues, and except my row count, which is supposed to be greater than 0, and in this case is 20, which is great. So what I would be able to do now is either publish it in the UI, and again, you can integrate it then with your Git's flows and so on. In this case, I'm going to keep it simple. I'm going to basically switch back to the YAML. And actually, I can see that everything that has been defined is here in the YAML. I'm just going to copy paste it in my Visual Studio so that actually I have the code version. And what I'm going to do now is just, again, running it locally with Soda Core to just make sure that everything is fine. And I can see that 18 checks have passed, everything is good. And then if I actually refresh my Soda Clouds, because I ran it with publishing. I can see now that all my checks were tested and visible here in the UI. And because we verified it with publishing, we also just published basically the version that I have locally to Soda Cloud. So basically the two are now in sync. All right. So now basically what we have is our full contract. We are covering all the requirements that we needed, and we actually executed the contract to make sure that the data is actually matching those requirements, which is great. But of course, it's only one part of the equation because now we have a contract which is tested, but it's not being tested every time that there is new data coming in. So that's where next to the CLI, we have also a Python API as part of the library, which allow you to basically hook into data pipelines to basically make sure that when there is new data coming that you can test it as soon as it arrives. And to showcase this, I, in this case, use Airflow. I'm basically going to show you how the Airflow look like and how you can actually integrate Soda into Airflow. So if I open my DAG here, it's a pretty simple flow here. We have 4 steps. The first one is load. What does it do, load? Because it's a demo here, basically what I do is just generating some random new rows for orders. And it receives one parameters, either as errors or true or false. And then if it's false or not provided, it's going to provide good data. If as errors true, it's going to provide bad data, which is going to make the contract verification failing. What we do then is that we are going to verify this data that has been created and push into a data frame. We are going to test the data frame to make sure that the data is correct. If it's correct, we are going to insert it into public. If it's not correct, we are going to stop the pipeline. And if it's inserted to public, so basically push to Postgres, we are going to then verify that what we push into the public is actually correct. So I will skip the step 1 because it's not really related to Soda. It's just about generating random data, and I will move directly to the verify locally to show you how you can do that. So just as a reminder, in this load task, what we do is actually creating a data frame, a pandas data frame in this case, which we are actually providing as a context within my step 2. And what I'm going to do is basically testing this pandas data frame with Soda. What I do here is basically making sure that, well, actually it's creating a DuckDB database and registering my data frame that was generated in step 1 within this DuckDB. Why do I do that? Is because Soda has a connector to DuckDB, which allow me then to test this data frame and make sure that the data within the data frame is correct. So once I have that, I have basically my DuckDB that is instantiated, and I have my data frame that I created in step 1 available within my DuckDB. The next step here is to create a temporary contract. Why do I create a temporary contract? Is because my orders table that I push into my DuckDB is available within my DuckDB at a different path than in my Postgres. I could have worked around it, but I kept it simple. So I just pushed it with the default location. So basically it's my DuckDB database / main, and so the main schema, and then basically the orders name here. So what I do here is that basically I take this contract that we created before. I basically take the first dataset property here. I modify this so that we actually point to the location within DuckDB. Once I have that, so I have a contract, like a temporary contract, which is basically just a copy of this, but pointing to the right place. And I have my DuckDB ready. So what I can do here is actually use Soda to register my DuckDB within the Soda context. And to do so, I'm going to do this. So basically creating a data source with DuckDB, which has the same name as my Postgres data source, so WebinarDB. And then I'm going to invoke verify contract locally, which is basically the function within Soda to basically execute my contract. So it get 2 things. One is the data source, which in this case my DuckDB, and the other one is the contract file path, which is in this case this temporary contract path that I just created. And using those two things, it means that basically the Python library is going to read the contract, identify which data source, which data set needs to be tested based on the data set property, going to connect to the data source, test the data, and return the results basically. And this result is going to give us few things, but in this case here, what we are going to do is use as part of the results the number of checks that have failed. And if it's greater than 0, it means that there are data quality issues. And in this case, I'm going to basically stop the pipeline completely from running so that we never publish the data. The last part, the next part is that if everything is fine, we are going to insert it into Postgres. Not going too much into detail here, but again, we take the data frame, we insert it into Postgres using Python, and everything should be fine there. And then the last part is basically step 4, where we are going to verify the data again, but on Postgres this time. So it's quite similar to what I showed in the step 2, except that here, instead of connecting to the Postgres data, the DuckDB database, we are going to connect to the Postgres. So here my data source file path is well, instead of providing the DuckDB, I'm going to provide a data source file path, which is going to basically point to the SodaDB config. And then the contract file path, which is going to be, in this case, the one that I created before, and then the Soda Cloud file path that I'm going to provide here, because we are going to do something slightly different from the previous step, where we are going to publish the results. So on the last step here, we're going to publish the result to Soda Cloud, so I can send notification if there are issues in production. We are not going to do it in the first step or step 2, because in this case, everything is contained within my Airflow, so there's not like really impact on stakeholders if there are issues. So I'm not going to publish and pollute Soda Cloud environments with things in staging. And once everything is done, basically, I'm just going to print either everything is good or things have failed, but that's basically the end of the pipeline. So how does it look like in my Airflow? So I did 2 runs before. Let me just start with the bad one. So if I look at my 4 steps, so I have here the loads, then verify locally, insert to public, and verify to public. In this case here, I actually trigger the pipeline with data issues. And I can see here on the load step, basically that I have, that's the rows that I am trying to push to the production. And I can see that there is an invalid status here, that there is a missing value in the status. And that's here, basically the shipping date is before the order date, which doesn't make sense. And because of that, when I execute the verify locally, I will be able to see here that there are, for example, a few issues with my shipping date, and after order date has failed because of the data that I just showed before. And I can see at the bottom here as well that there are 2 issues with status, one being that there is a missing value and the other one is invalid. And so in this case here, I can see that there are 3 checks that have failed. And because of that, I'm going to stop the pipeline. And so the insert to public and the verify public will never happen. On the other side, if everything is fine, so here in this case, I loaded the data, which is all good. So in this case, everything is complete and there is all the things that I am expecting. So everything is good. So in this time, basically, when we look at the summary of Soda executing locally, I can see that the 16 checks are passing. So in this case, I can insert it and then I can test the data after being inserted, and I can see here that everything is fine as well. And in this case, we are going to basically push that result to Soda Cloud, so that again, it will be visible here on this page. All right, so while it's loading, just then to recap this part, which was basically the main demo of today. So what we did here is basically as soon as there is new data, make sure that we can actually test this data before we even push it to production. If there are issues there, we are going to actually stop the pipeline. So we make sure that the data that is available to downstream system is always good quality. And so once the data is good, we are going to just verify it again to make sure that what is in production and what we think is good quality is actually good quality. And this way you really prevent that there are any issues in productions and make sure that what is there is always high quality and matching the data contract that you have defined. And the last part is making sure that those results are pushed to Soda Cloud and to over integration like Slack, Catalog, and so on, so that basically stakeholders using this data can basically understand what is the current quality. All right, just a last part before we move into the Q&A and wrapping things up. So as I demonstrated in the previous workflow, we actually have a part that is codes version, so based on YAML, but we have also a UI workflow. So basically through the UI, you can create contracts. Basically, the goal here is that we can bridge the gap between technical users and less technical users, for example, the stewards or analysts and so on, so that everybody can actually contribute to the data contract. So just to go back here into my Soda Cloud, basically, even if I'm somebody less technical, and let's imagine that I want to basically propose changes to this orders table. So let's say I'm basically an analyst using this table. I'm not the one responsible for this contract. I can actually come in this page, view the contract, and I can even propose changes here, which is quite nice so that you can have less technical users actually propose changes to the owner of the contract so that they can implement it. And the goal there is that basically instead of having people creating tickets, asking changes and so on, that we can really push everybody to participate and to implement changes as we need it. So let's assume quickly that I come here with a certain use case as an analyst, and I want, for example, that country code doesn't only respect a certain rule of like the lanes, but also make sure that it actually match a reference table. And for example, I want to extend the valid status with 2 extra values. I can actually come here, again, use Copilot or use a UI. This is going to add the checks that I need for my use case. I can see that the checks were added here, and I can actually not only, well, in this case, not publish it because I'm not the one owning the contract, but I can actually create a request. And the request is going to allow me to basically, for example, just putting the context here. Let me just switch here. And just create here basically a kind of a ticket actually, where basically we have the context of why I'm asking certain things, but not only that, but also actually proposing changes directly to the owner of the contract so that they can actually review it and they can see what I've changed here. They can propose alternative and they can test it and then push it into the engineering workflow with YAML and so on. So that's here really the intent was or is to basically bridge the gap between data consumers and data producers, less technical users, so that we have a workflow which is easy for everybody and have a way to basically align our requirements, not only from like a text point of view of like this is what I need, but actually to the implementation level where you can really close the feedback loop and go as fast as possible into implementing requirements for business cases. All right, so that's basically what I wanted to show today. So just as a reminder, we are going to send a Git repository link after so that you can play around with it if you want. And I think we are already a bit late, so I'm going to open the Q&A and see what questions are. So if you have any questions, feel free to use the Q&A section, which I will review right now. Thank you. Let me take the first question. So that data contract versus DBT data contracts, schema YAML as the DBT schema YAML also handle documentation, primary key, foreign key, and tags. which can be used and made visible in Snowflake Databricks coexistence. How? That is indeed a good question. I think Mafalda, you're going to answer the question, or are you going to do it live? Or okay, sorry, I got no worries. So basically, I think it's easier to actually use one or the other. I think here the value of Soda is, I think most of the value there is what I've just shown at the last part, that we are bridging the gap between technical users and less technical user, where DBT is a bit more technical. But I think having two or three different versions of data contract is maybe not advisable because you would duplicate a lot of information. The next question is the data contract applied to data set or data product? We use Colibra as a data governance tool. Sorry, something just. The way see data contract is that it should be governing a data product. So at Soda, we actually went on the physical level, so per data set. We are going to look into bringing a data product concept later on, which would be a collection of data sets or columns that you are using into a certain use case. But what we wanted to do is making sure that really at the data set level, you can enforce things because data products can evolve over time and so on, where data sets usually, well, you might add a few columns here and there, but normally they are pretty stable. So we started with the data set level. Next question. We use data contract to drive our data pipelines. We adhere to the ODC, so the Open Data Contract Standard. If you decide to adopt SODA as data observability tool, will our data contract be compatible? That is a good question. I think you would have to rewrite it. One thing to know is that what we built as data contracts, so our format is quite extensible. So I've shown like the properties that Soda is using, so mainly the columns and the checks. But you can add multiple or extra properties. So there is kind of free form if you want to add extra properties to your data contract so that you can use it in different use cases. You can do so. But it might still mean that you need to rewrite a few parts here and there as well. All right, does publishing result count toward the cost of Soda Cloud? Indeed, the licensing model of Soda Cloud or Soda is basically a number of data sets that is being tested. So as soon as you have basically a contract with result, we count it as a tested data set. Does the contract support SLA and ownership definition? It's mainly for data quality or schema check. A bit going back to what I was saying regarding the point of open data contracts and what we support in Soda. So at this moment, the focus of Soda and data contract is indeed mainly around data quality, making sure that basically you can document what can be missing, valid, and so on. But as I mentioned, you can always extend the contract with extra properties that you have the use case for example, SLA, ownership, and so on. And because it's a YAML, you can always integrate the YAML with other tools. So for example, if you want to create an automation to basically push this ownership information to a catalog, for example, you can actually parse the YAML and push it with the API of the catalog. So there is pretty open. You can add as many as you want, but at Soda, at least at the moment, what we act on is basically the checks that you have defined. Can we run the checks again in Spark data frame so that it runs the data quality check before the table is written? Or will it then provide an option to allow writing the corrupted record into a quarantine table? That's basically what I've showed today with DuckDB. We also support Spark Data Frame, so that basically would work the same as what I've demoed today. We are also building a capability, which I didn't have time to show today, but that's something that is going to come soon, and we are going to add support shortly next year on Spark Data Frame. To basically every time that there are checks that are being executed, that we basically allow the ability to either collect the primary keys of those table rows, sorry, or composite keys of those table rows. Come on. Or even copy the full rows into a quarantine table. So that's something that would be automatically done by Soda if configured, and then they can use for basically workflows to solve the records. All right, next one. Or are the records that fail checks can be quarantined until reviewed and a workflow to push them to reviewers, which basically link towards what I just mentioned. So that's a capability that we are building and releasing as we speak, actually, which is called the diagnostic warehouse, which is going to basically allow you every time that there are checks failing to extract that information so that you can build workflow on that. And the idea there is also that basically everything will be available within your database. So you can actually use the data to build reports, to build workflows, and so on and so on. Next question. Is there an adoption for configurable data promotion gates? Not every DQ failure should result in a block. That's a good question. I didn't show it, but basically when you define a threshold, so you can define a threshold to basically say how many missing values you tolerate, like a percentage or invalid values and so on. But you can also define the level of failure. So you have two levels, either warning or failures. And then one is a warning, basically, that means that it will not show as a failure from the result. So you can actually discard those and keep on processing like the pipeline, for example. So that gives you basically indication which checks are failing, passing, or warning, and then you may decide what you want to do with it. And the last one for today, any way to integrate things so that tickets with our standard tools like Jira, GitHub, and Asdo. So we have for our capabilities APIs that you can use. So we have, for example, an incident capability when there are issues that you can create an incident on top of a check that is failing. And that's the ability through webhook API and REST API to actually create automatically an incident in your Jira, for example, and when your Jira is updated, sync that back into Soda. And you can do the same, for example, with your contract lifecycle. Every time there is a contract that is being published, you can configure a webhook to be sent. So you can actually listen to this webhook with GitHub as an example and make sure that you store the new version in your Git, or the other way around. For example, if you create a pull request and you want to automatically publish the contract, you can use an API to do so. All right, any other questions? Otherwise, I think we are right on time. Again, we are going to send the recording of the demo or the whole presentation of today, as well as a Git repository so that you can play around with it. And just to wrap it up, if you want, there is also additional resources. So we have documentations available at docs.soda.io, where you have everything around data contracts, observability, and all the things that we are doing. And then the last one, if you are interested, you can, of course, book a demo with our team to go further into your use cases and how we can support that with our product. Thank you a lot for attending today, and I hope it was useful and insightful. Thank you.